Folks, today the question I have is 2020 May June paper 1-2 and the question number is 9. As you can figure out from the diagram, it is concerned with the chapter dynamics, since it is dealing with collisions. It says a mass m1 traveling with the speed u1 collides with a mass m2 traveling with the speed u2 in the same direction. You can see in the same direction. After the collision, mass m1 has a speed v1 and a mass m2 has speed v2 in the same direction. The very simplistic example. The collision is perfectly elastic. So which equation is not correct? So let us go for the equations which we can recall when we deal with elastic collision. So the equation we can recall is one of the equations is this. It is 1 by 2 m1 u1 square plus 1 by 2 m2 u2 square is equal to 1 by 2 m1 v1 square plus 1 by 2 m2 v2 square. So this means total KE before collision should be equal to total KE after the collision. Then another equation is about the relative velocity of approach before collision and the relative velocity of separation after the collision. So before approach, the relative velocity is equal to u1 minus u2 equal to, then the relative velocity of separation is v2 minus v1. So these are the two equations we obtain when dealing with elastic collision. So let us see which one among these resembles this and which does not. So the first one is this. So this comes from somewhat like this. So when in this equation, let me cancel this half that goes. So what I can have is, so let's bring v1 here. It will give me, from this I can obtain m1 u1 square minus m1 v1 square equal to m2 v2 square minus m2 u2 square. So this is true. So this is true. So it doesn't qualify for the answer. So this doesn't qualify for the answer. So next is v2 plus u2 equal like this. So here let me change this equation. When I change this equation, I will have so this u1 is here. Let me bring v1 here. So plus v1 equal to v2 is there. Let me take this u2 there. So plus u2 plus u2. So u1 plus v1 equal to v2 plus u2. So v2 plus u2 equal to, just switch off side. So this is also true. So it doesn't qualify for the answer. And next is about momentum. So momentum is always conserved. Whatever be the type of collision, the total momentum is always conserved. So that's why. So this thing starts from this. So we'll have a total momentum is same. It should be m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. So if I bring the quantities with m1 to one side and with m2 to the other side, I will have m1 u1 minus m1 v1 is equal to m2 v2 minus m2 u2. So this gives me m1 bracket u1 minus v1 is equal to m2 bracket v2 minus u2. So this is also true case which does not qualify, and the only thing remaining is choice number D. So choice number D is a wrong thing. It's a wrong thing because actually it is trying to deceive us. So it is just trying to get our mind intermixed with this one. So in equation 1 we have this thing. So m1 u1 square minus v1 square is equal to m2 v2 square minus u2 square. So this thing confuses with this thing, gets confused with this thing. So here this is true. So what happens is, when I open up the bracket, it will be u1 square plus v1 square minus 2u1 v1. So definitely that thing cannot be equal here. So this thing is untrue, and it qualifies as the correct answer because it says which equation is not correct. So we have to go for the wrong equation. The wrong equation becomes the right answer. So this is the proper answer choice.